Hello guys, welcome to Concept SR. In the last lecture, we have studied about the formula of Newton's law of cooling, and today we will solve some problems. So let us proceed with this. Just for the reminder, we had a formula for the Newton's law of cooling. It was theta minus theta naught is equal to C into e power minus kt. Correct? So this formula we had. Okay, moving to the question. So. Okay. So question says if the temperature of the body is changing from 100 degrees Celsius to 70 degrees Celsius in 15 minutes, find when the temperature will be 40 degrees Celsius if the temperature of air is 30 degrees Celsius. So again we got theta and theta naught both here. So let us see part by one. Just a minute. So let theta 1. If the temperature of the body is changing from 100 degrees Celsius to 70 degrees Celsius, let theta 1 is equal to 100 degrees Celsius. Theta 1 is equal to 100 degrees Celsius to 70 degrees Celsius. So theta 2 will be 70 degrees Celsius. See, it is changing from 100 degrees Celsius to 70 degrees Celsius in 15 minutes. So initially it was on 0 minute, and within 15 minutes the temperature reduced to 70 degrees Celsius or changed to 70 degrees Celsius. Now it says find when the temperature will be 40 degrees Celsius. So it is this question is simply asking that theta 3 at 40 degrees Celsius. Okay, okay, it's my mistake. So this question is asking about the T3 when we will get 40 degrees Celsius as a temperature given theta naught is equal to 30 degrees Celsius. See, here it is. The temperature of air theta naught is 30 degrees Celsius. Okay, now we will move step by step. So first we will take, so we know the formula here. It's let at t is equal to 0 1 theta minus theta naught is equal to c into e power minus kt. We have this formula for Newton's law of cooling. Now if we take this theta 1, so if we can write it as 100 minus theta naught is 30, temperature of air is equal to c into e power minus k, and what is the time? It's 0. So simply we can solve it as 70 is equal to c into e power 0. K into 0 will be 0. Simply e power 0 is equal to 1. So c is equal to 70. Now we got the value of c here. Now again second step, at t is equal to at t is equal to 15. This, we know that we have formula theta 2 minus theta naught is equal to c into e power minus kt. So what is the value of theta 2 here? It's 70. So it's 70 minus, and we have theta naught as 30. Theta naught of the surrounding is equal to c into e power minus kt. C we got as 70, and it can be written as e minus k. And what is the t? It's 15. Now it will give us 40 is equal to 70 into e power minus 15. It can be further written as 40 by 70 is equal to e power minus 15k. When we will solve this value, 40 by 70 will get some value, and e power minus 15k. When we will remove this e, this will go this side, and after calculation, it will the log will come here. Okay, I will show you. So it will be like, so 0 and 0 will be cancelled here. 4 by 7 we got equal to power minus 15k. Now it will be log 4 by 7 is equal to minus 15k. Whenever e is removed here, we will get log here. So after calculation, you will get log 4 by 7 is equal to, you will get the value of log 4 by 7 as minus 0.24. So here from here, we will get k as 0.016. So, so now we have got C and K. Now moving ahead, at T3, at T is equal to what we have. Okay, so at theta 3 we have to find the T3. Okay, we have to find T3. So theta 3 minus theta naught is equal to C into e power minus kt. We have theta 3 as 40 minus theta naught is 30, and it's like C. Okay, so we have C into e power minus kt. 40 minus 30 is equal to 10, and we have C is equal to 70, so we will bring down here, it will come 70, and it will be e to the power minus 0.016 t. We just calculated the value of k. C. Now 0 0 will cancel. Moving further, 1 by 7 is equal to equal minus 0.016 t, and if we will remove the e here, so log will come here. Log 1 by 7 is equal to minus 0.6 t. It's 6. Now we get log 1 by 7 is equal to minus 0.84. Approximately we'll get this. It's minus 0.016 t. Now when we find the value of t, it will come as minus 0.84 divided by minus 0.016, and we will get, if we will calculate this value in calculator, we will get the value of 52.5 minute. and this is the required answer. Have you seen how easy is this? Just we need to remember this formula. That's it. And some small calculations. You can easily solve it. Whatever, whichever question is. So moving ahead to the next question. So here we are. So we are here with a new question. So let us read first. A body kept in air with 25 degrees Celsius. A body kept in the air with temperature 25 degrees Celsius cools from 140 degree to 80 degree in 20 minutes. Find when the body cools down to 25 degrees Celsius. Okay, so we have some data, so we'll write it. A body kept in air with temperature 25 degrees Celsius. So air with this line, we understand that theta naught is equal to 25 degrees. Okay. Now, question is also saying that theta 1 is equal to 140 degree Celsius originally, and it reduced to theta 2 80 degrees Celsius in 20 minutes. Now, find when the body cools down to 25 degrees Celsius. So theta 3 is given, and we have to find the T3. Okay, so this is the required data we have. So we will solve it again like that. It's very simple. At t is equal to 0 minute, we have theta 1 minus theta naught is equal to c into e power minus kt. Now theta 1 is equal to 140, theta naught is equal to 25 degrees Celsius, c e power minus k, and t is at we are calculating at 0 minute. Now what is the value of 140 minus 25? It's 150 is equal to c into k into 0 0 e power 0 1. So we got c is equal to 150. Now we'll move ahead. Second, at t is equal to 20 minutes. This one first is completed. Now we are going to second one. Theta 2 minus theta naught c into e power minus kt. Theta 2 is what? It's 80 degrees Celsius minus 25. Yep, 25. And we have c right now here, 115 e power minus kt. So what is the value of 80 minus 25? So it's 55. Just a moment. 115 into e power minus k. And what's the value of t? It's 20. Now this will go downside. 55 by 115 equal to e power minus k 20. Or we can also write it as log 55 by 115 is equal to minus 20. This e will come there and it will become log, and this will, that rest minus 20k will be left. So what is the value of log 55 by 115? Let me check. It's minus 0.32. Minus 0.3. This minus this and minus and will cancel. So k is equal to minus 0.32 by 20. What value we will get? It's 0.016. Now we get k value, we get c value. Now we'll move ahead with theta. Now for theta 3, we have to find t3, right? And theta 3 is given as 35 degrees Celsius. Right? So again we will use that formula. Theta 3 minus theta naught c into e power minus kt. What is the value of theta 3? It's 35. We have theta naught as 25. Yes, theta naught is 25. C value, what is the value of C? It's 115. 115. E minus, we have also have K value. It's 0.016. So we have to find this value T. So we'll solve it. So it will become 10 is equal to 115 into e power minus 0.016 T. Yeah. So again it will become 10 by 115. This will go down and it's e power minus 0.016 T. Now it will come log here 10 by 115 is equal to minus 0.016 T. Now log 10 by 115, it's minus 1.06. Correct? So we will get the value of T is equal to minus 1.06 divided by 0.016. So what is the value we are getting? 6.2. So we got T3 is equal to 66.25 minute. See how simple it is. Now the next question is very interesting. So you will feel like you are a investigator, and let's see what happens. So next question will be based on a murder mystery, which is really interesting question. You will feel like you are solving some murder case. Okay, so we will move to the next question now. So here is the murder mystery question. You can see that. The question says like a murder victim is discovered and a lieutenant from the forensic science laboratory. So it's obviously you guys, uh, lieutenant from forensic science laboratory. It's someone to estimate the time of death. And the body is located in a room that is kept at a constant temperature of 68 degree Fahrenheit. See, not is also there. This. The body is located in a room that is kept at a constant temperature of 68 degree Fahrenheit. The lieutenant arrived at 9:40 p.m. and measured the body temperature as 94.5 degree Fahrenheit at the time. Another measurement of the body temperature at 11 p.m. is 89.2 degree Fahrenheit. Find the estimated time of death. Okay, so we will go like that. We done previously, same in the same way. So what are the data we have? First of all, we have theta, that is 68 degrees Fahrenheit. Okay, the lieutenant arrived at 9:40 p.m. Okay, and measured the body temperature as 94.54 degree Fahrenheit. So theta 1 will be 94.4 degree Fahrenheit. And what will be the time? That is the first measurement, so we will take it as 0. 0 minute. Now again at 11 p.m. that lieutenant came and noted its body temperature. It was 89.2 degree Fahrenheit. So theta 2 will be 89.2 degree Fahrenheit. And what will be the T? So here is a small concept. First temperature noted at 9:40 and second as 11:40. What is the difference between these times? So if we will calculate, so it was 9:40 p.m. and then again at 11 p.m. So I think it's total a difference of 120 minutes. Sorry, my bad. It's 80 minutes. Right. So the T2 will be 80. T1 and find the estimated time of death. So we have to find the time of death, but here theta is not given. So how we will do? A small concept. What is the normal temperature body of a human? When he was killed or at the time of death, his body is obviously its normal temperature. So normal body temperature is 98.6. So we'll assume theta 3 like that. Okay. Now it became easy for you guys, and we will solve it now. So we are going to solve a murder mystery now. At what time the person died? Okay. So at t is equal to 0, we have Newton's law formula theta 1 minus theta naught c into e power minus kt. What is the value of theta 1? It's 94.4. Body temp theta naught is 68.5. C we don't know, E minus K, T we know it's 0. So what is the difference between this? Let me calculate. 94.4 minus 68.3. It's 26.1. Let it take approximately 26. See value 26. It will be easy for you guys. Now, second time at T2 at 18 minutes. What is the Newton's law of cooling formula? It's theta 2 minus theta naught c into e power minus kt. Theta 2 is 89.2 obviously, and theta naught is 68. We got the c value as 26 minus k, and the value of p is 8. Now 89.2 minus 68, we got 21.2. 0.2 is equal to 26 into e power minus 80k. Now, what is the value of 21.2 divided by 26? Right? It's 0.8. Now, again, we can take it as log 0.81 is equal to minus 80k. So, log 0.81 will be minus 0.09 is equal to minus 80k. So, the k value will be 0.09 by 80. This minus and this minus will be cancelled. So, we will get the value of k as okay. Let us keep it as say 0.09 by 80. Now, moving ahead. Now, we will come to theta 3 at t is equal to t. We again have formula theta 3 minus theta naught is equal to c or minus kt. So, what is the value of theta 3? It's 98.6. Normal body temperature. Theta naught 68 degree Fahrenheit. What is the value of c? C is 26. 26 into e power minus k minus the k value is 0.09 by 80 into t. Find this variable, this t. So, what is the value of 98.6 minus 68? It's 30.6. Can keep as 26 down is equal to e power minus 0.09 by 80 t. Now again we can write it as log 30.6 by 26 equal to e minus 0. Sorry. So it will go. Now e will be removed. So it will become simply minus 0.09 by 80 into t. So the value of log 30.6 by 26, it's 0.0707, and the value of, so let it be 0.09 by 80 into, now we will get the value of ts when we will do multiplication. It will go like 0.0707 into 80 divided by 0.09. So what is the value of this? 62.8, or simply we can take it as 60 minutes.